Okay, so we're chapter 8, we're on day 2. This is the first part of it, day 2. So what we have here is we have the results on the calculator from looking at the relationship between the SAT scores and the freshman year GPA in college. And we have that the slope of the data, or the line of best fit, is 0.0039 and the y-intercept is negative 1.47. So let's take a look at the equation for line of best fit in a little more detail. Now, we saw that the equation for the line of best fit is written as y hat is equal to b0 being the y-intercept plus b1 times x, where y hat is the predicted value, b0 is equal to the y-intercept, b1 is the slope, and x is the explanatory variable, or your x-axis, or your independent variable. So you plug in an x, you multiply it by the slope, add the y-intercept, and you get the predicted value, the value on the line of best fit. But there is more information that we can do from this, because if you look at the formula sheet, there's a lot of other formulas that are involved with this. The two that we need to look at, however, are these. We also need to look, not that one, we're going to look at that in just a second. Let's insert, no, let's just write it right here. Okay, so our other equation that we're going to talk about is this. B0, the y-intercept, is equal to y bar minus b1 times x bar. Now, y bar would be the mean of the y variables in our situation right here. Y bar would be the mean of the freshman year GPA. B1 is going to be the slope. X bar is going to be the mean of the x variable, or the mean of the SAT scores for us right here. So here we have y bar and x bar. We talked about the mean point. There it is right there. That's actually the mean point. There's the mean in x and there's the mean in y. The other formula that we're going to talk about here is finding the slope. Slope is equal to r, which is the correlation coefficient, times the standard deviation of y over the standard deviation of x. So I can find the slope if I have the correlation coefficient, the standard deviation of y, and the standard deviation of x. If I have the slope and the mean of x and the mean of y, I can find the y-intercept. If I have the slope and the y-intercept, then I have everything I need for the equation of line, for the line of best fit. Where would I get these variables? Well, y bar and s sub y would come from doing one variable stats for the y variable if you had that data, and x bar and standard deviation of x would come from one variable stats for the x value. And the correlation coefficient, well, you'd either be given that or you'd have to find it yourself by doing the correlation coefficient, the linear regression. Of course, if you did the linear regression, you'd get this information anyhow. Why do I need these things? Well, it turns out that you are going to, at some point, be given a problem that says, given this information, create the equation for the line of best fit. Or, given other information and the equation, fill in other pieces here. So what we're going to do is we're going to start with this problem. This is the first problem, 1A from the text, and it says basically fill in the rest of the information in this table, and they're giving you x bar is 10, standard deviation of x is 2, y bar is 20, standard deviation of y is 3, r, the correlation coefficient, is 0.5. We want to find the equation for line of best fit here. Very first thing I need to do is I'm going to need to find the slope. We're going to start off with the equation. You know what? I'm tired of red. I went green. B1 is equal to r times the standard deviation of y over the standard deviation of x. Let's fill in what I know. I know what r is. R is 0.5. Standard deviation of y is 3. Standard deviation of x is 2. So what does this simplify down to? Well, what I'm looking for is 0.5 is half. I'm looking for half of 3 halves, or half of 1.5, and that would be 0.75. So it tells me that my slope of the line of best fit is 0.75. And it's positive, but I knew that because the correlation coefficient is positive, and they're going to be going in the same direction. Now, with the slope and the mean of x and the mean of y, I can then find the y-intercept using the equation b0 is equal to y bar minus b1 times x bar. Y bar is 20 minus B1 is 0.75 times x bar, which is 10. So, if I simplify this, 20 minus 0.75 times 10 is 7.5. 20 minus 7.5 is 12.5. And now I can fill in my equation for line of best fit. Let's get rid of this so I've got all the room I need. I would say y hat is equal to B0, y-intercept, 12.5 plus, it's positive 0.75 for the slope times x. There you go. Actually not that hard to do. This didn't start. So we're going to pause there and we're going to go on.